Hello, everyone. I'm very excited to be here today and talk to you about reflection. And I hope you're as excited as I am about this feature. So welcome to version 1.0 of the metaverse. So for those of you who doesn't know me, my name is Inbal Levy. I also put here a QR code for you to be able to scan and also the link so that you can follow the slides. This talk contains quite a lot of Godbolt links so that you can experiment with, and I'm sure it's going to be more interesting to review it this way. So please feel free to enter the slides. Meanwhile, I'll tell you that I'm a C++ software developer. I also am very excited to be here in Pure Virtual as I recently joined the OS Internals group in Microsoft. I'm an ISO CPP Foundation and Boost Foundation board member and active member of the ISO CPP committee. So the CPP committee is the one that is in charge of basically publishing the C++ standard every 3 years. As part of my roles, I'm the Israeli National Body Chair and Library Evolution Workgroup Chair. So Library Evolution is the group that is in charge on the standard library design of the standard library. All right, cool. So what is reflection actually? Reflection is the ability of a software to expose its internal structure. And the idea here is that you have a program and you can observe another program. So when I talk about reflection in C++, and by the way, in Rust as well, I'm talking about static reflection. You may be familiar with reflection from Python, but that's not the case here. So we're talking about compiler that basically looking at our reflection syntax, translate that into a valid C++ syntax, and then this is being compiled to a binary, and there's nothing left in the binary to indicate that it came from reflection. So of course, this addressed concern like performance or security, but also it's possible for users to basically write their own code to preserve this information, but that's not part of the feature in any way. And this was discussed also quite heavily when this feature was first starting to become to come to existence. So, sorry. We have two parts of this talk. First part is intro to reflection. I'm going to go over a brief history of the reflection proposals in C++. Go over the latest proposal, that is P2996, one that is slated for getting into C++ 26. And at this point, I want to mention that we are in a very interesting point of the cycle of the standard. So we have basically what is called feature freeze, and that is we already finalized all the features that are planned to get into C++ 26. But we're now finalizing the fine graining and finalizing and fixing bugs and things like that, addressing reported comments, that is NB comments. So until the document is signed, we cannot know for sure which features are going to get in, and that's going to be sometime next year. But still, I'm very optimistic regarding the reflection proposal because it got a lot of support. So when I say it's going to land in 26, if I say that throughout the talk, please take this with a grain of salt, as it haven't been signed yet. I'm still, I'm very, let's say I'll be very surprised it will be pulled away. So latest proposal, as I mentioned, we're going to talk a bit about the complexity of reflection. And the second part is going to talk about the impact on our code bases. So we're going to look at reflection-based libraries, some examples, and talk about what's next. Another thing I wanted to point out is that the examples here that you can use, to get into the Godbolt links and experiment with, have been basically derived from the P2996 paper. And I also want to point out the Wired Charles and David van der Voorde, and that led basically implementation for EDG compiler, and Dan Katz from Bloomberg for leading the implementation for Clang compiler. So thank you very much to those people for working on those implementations, because that allowed you to experiment with and enjoy, even before the feature have been published officially. So let's start with a quick, brief history review. So in 2006, it was the first time I've recognized the reflection being mentioned in context of C++. And that was for by Matulkolchik that had a mirror reflection library. This library was heavily related on template metaprogramming, with techniques that you are familiar with. In 2012, we had a paper by Mark Spartus, and he tried to enumerate use cases for reflection. So again, things like getters and setters, serialization, wrapping types, and customization point. He didn't call that in that term, but that was the intention. So that's very interesting to follow up and see what actually made it and what actually is supportable by the proposal. I'll give you a hint. Not everything that I mentioned is directly supported. Between 2014 and 16, Matush was trying to standardize his library. And again, that was multiple papers. And as I mentioned, having a proposal requires some process in getting into the standardization. But in 2015, we had an implementation of Boost HANA by Louis Dion, and that was a template metaprogramming library and heavily relies on template metaprogramming. And at that point, it became clear that template metaprogramming is not necessarily the best tool to achieve reflection from two reasons. One is that the error messages from template metaprogramming is not necessarily indicative, and it can instead of coming from the logic, it can come from the technical implementation, which makes it harder to basically for developers to use. But the second more significant problem was that the compiler had a hard time. Compilers had a hard time basically implementing that in a way that will be feasible. So I used to work in a large project, and the linker were failing to load all the symbols to memory, and that was not even a significant project as others might be, like for example the one I'm working on now, which is the OS Windows source code. So at that point, there became clear that we need a different tool, and the different tool was specialized syntax. So we had a few proposals trying to suggest the specific syntax, and we also had the term meta object coming up. So I'll go back to that, but I just wanted to also highlight the fact that in 2018, we already had a proposal or paper in the domain of reflection by Bjarne Stroustrup, the inventor of C++. So you definitely can see that this feature is getting more and more traction. We had Reflection TS by David Senkel. TS is a technical specification, and that's a document tries to basically clearly specify all the details of a feature. And we had, again, going back to the term meta objects, we had some arguments about type-based versus value-based, etc. So I would explain on that a bit. So if you want to represent your program, let's think about the program as a project. You'd probably think of like as anything else, any other program that you write that tries to represent information from the real world, you're probably going to consider hierarchy as one of the options. So you could consider things like creating a type that is a function, and then inheriting from that for a static function or member function, etc. But that turned out to be quite heavy again for the compilers, because then they had to preserve this to have this full a hierarchy model to save of all the entities in the program. By the way, I will refer to that further. But then we settled for something that is a single object, that is what is called value-based reflection. And that is what we now have as stud meta info object. So also constexpr was also around that time was getting more and more support. More and more things became constexpr, but still constexpr by itself is not enough to basically have a generative code. So in 2020 and 21, we had some discussion on syntax and naming, naturally. And we also had another paper talking about the value versus type-based. But in 2023, we actually had our reflection proposal, the one that, as I mentioned, slated for 26. And I want to mention the authors, Barry Razvin, Wyatt Childs, Peter Dimov, Andrew Southern, Faisal, I don't remember your last name, sorry, and David van der Woede. Thank you very much for working on this proposal. I'm very, very grateful, and I think the community also is very grateful. We had a few more proposals trying to basically utilize the syntax that is being proposed and apply that to use cases like binding and also observed some bug fixes that I'm going to refer to later. But today we're going to talk about the latest proposal 1.5 years later. We are now at revision 11. So what do I mean by reflection? I already gave you the general terms, but now I want to give you a bit of code snippet. So we have here a library type. It inherits from base 1 and base 2. And here we have this reflection expression, and we basically take this lib type that we defined, and we lift this using the lift operator to reflection realm. So of course I'm using this terminology. It's not in the standard in any way, but I'm using this to emphasize the ideas behind this. But now we have this std meta info object that represents lib type, and I can put this expression in meta function. So this is std meta basis of, and basis of would return as according to the name a vector of std meta info objects that is the basis of the class, and this is according to declaration order. So if I reach out to the first element of the vector, I'm going to get base 1. Cool. So the reflection paper, now that you know what it is, basically have four main parts. The reflection operator you're already seeing, splicers, which is if reflection operator, lift operator is basically taking things from C++ realm into reflection realm, splicers take them back to C++ realm. We have std meta info object itself being proposed into the standard, and we have a bunch of meta functions. So I'm not going to go over all of those meta functions, but you can already spot some names that might resemble type traits. And the reason is that we've basically, it was a lot of discussion, but those all are under std meta namespace and not like the type traits on traits. And the reason we added them is because those can get compiler intrinsic support and basically work better with the reflection utilities. So it's definitely resembles that, but it's different implementation, or could be, because the spec never talks about implementation, but definitely allows that. And we're going to see, I hope, in the upcoming years, the impact of that. So we also had used to have reflect expression, and it turned out that constant expression is too much to promise. Therefore, it was replaced with reflect value, reflect object, and reflect function, and define aggregate. For those of you who have been, if you have been following the proposal, at some point it had define class. Define aggregate is an extension. On top of that, it can, on top of defining structs, and it can define arrays and unions, etc. Right, cool. So lift operator. So we used to have a single caret, and then basically to avoid ambiguity with other language, we had to turn this into double carets. So if you want to use the nickname for that, you can use Unibro, which was suggested by J.F. Bastain. He's the chair of evolution work group. So as I mentioned, I'm the chair of library evolution. That's the group in charge of the standard library. Evolution is the group that is in charge of syntax of the and the programming language C++. So I'm really grateful, and there was a lot of collaboration between us. But yeah, feel free to use Unibro, just give credit to Jeff. But going back to our operators, so this line that you see here, I'm taking an int, which is a type in C++ realm, and I'm basically lifting it. But this line doesn't work as is. And if I could take hands from you, probably have multiple guesses or multiple answers. I'm sure some of you would have catched that, but I did mention that quite extensively already in the beginning of the talk. We have to have things that are available for our compiler to execute on. So the reflection expression itself have to be const expert so that the compiler knows it can activate logic on. So now it's fixed, and again, we can take the things into reflection realm and then splice them back using these operators that you see here back into the C++ realm. So the type name here is the canonical way to use splicers, because when some cases, you might need to disambiguate that and make sure the compiler understands that this is a type and not something else. But generally speaking, you don't have to use type name. You could use splicers in the general case, and only use this for disambiguity. But I did wanted to give you like the canonical way to, in case you want to experiment it later. So yeah, now we're taking things back from reflection realm back to the C++ realm. So let's do a small recap. What is reflection expression? Reflection expression is the meta info object that represents int. And what is, again, ignore this type name for a second. What is reflection expression in splicers? Well, this is just an int, right? I'm going back from this to that, and I can actually declare here int a equals 42. That's what happens here. So again, if you want to read a bit more about the type name and disambiguity, please go into this link. It's really specified well in the proposal. So we talked about reflection operators, splicers, and meta info. Let's talk about something else, a bit more information about meta info, and then go back to our proposal. So what we have here is what is called AST of Clang compiler. So AST, for those of you who have taken compiler course or just explored on how compilers work, AST is an abstract syntax tree. So this is basically when you take a C++ program and you parse it, you want to represent the program in some kind of a model, a programmable model that you can actually use. So you have here basically things like function declaration, that's our main, variable declaration, I, which is the name, and int, which is the type, and the fact that it's an L value, etc. So I hope you now see some connection between the student meta info and what I mentioned about the information about reflection. So and the AST. So definitely student meta info can contain type and type aliases, functions, variables, etc., enumerators, template namespaces, and so on. But you need to pay attention to those two lines. Object that is a permitted result of a constant expression, and value that with structural type that is a permitted result of constant evaluation. And the second one should probably resembles, for those of you who are familiar with NTTP, non-type development program, this kind of restriction resembles that. But we used to have a restriction for constant expressions that was discarded in quite early stage of the proposal due to the fact that we found out that making promises for expressions in general is a bit problematic due to side effects. So long story short, that's an error on what was in earlier stages, but we can always extend proposals later or add on top, but it can't take back promised usability. So again, looking at this example quickly, we can see here that I made the reflection operator const expert, but also this would not work because I have here an int, and I need to have something that the value that I want to reflect on have to be available at compile time. So that's again emphasizing what I said before. So yeah, let's quickly talk about some meta functions. So again, the idea of meta function is that I can take something, I can lift it, and then I can operate on it. So this is an update for basically the latest state. And the latest state we used, instead of name of, we modified the name into identifier of. And the reason is that in C++, names are, they can be context dependent. And like, for example, you can have a fully qualified name with the namespace or something else. So instead of going in that direction, we modified it to identifier of to make sure we don't clash or close the design space in the future. So all meta functions take info, or apart from those three that I mentioned here, they take the type, and return string view, stud meta info, vector of stud meta info, boolean, size t, source location, etc., and member offset, which is a type that we define for bit fields. So let's we talked about reflection, and let's talk about a bit about some interesting non-intuitive things that we have in this proposal. So I have here a class. I have a declaration of a class. And for those of you who are not familiar with the term complete type, is that I can declare a class and I can define it. And until the compiler knows what's the structure of this class, it's going to be considered as incomplete type. So I declare the class, I lift it to reflection realm, I use this expression to give it to a meta function, and I query is complete type. And at that point, you probably can guess that this returns false. So now I look at this class after being defined, and I do the same thing again. I take a reflection expression, I execute is complete type, and I get back true, right? Because at that point, we already know that this has been completed. But the question is, what am I going to get if I'm taking result one, the one that we've defined in line 6, and execute the function here? So the two options are true or false. And the option that is here, naturally, as I'm showing this to you, that as something that is less intuitive, I think, is the fact that this would return true. Because despite this looking like a value that we're taking, or a snapshot of the AST, that's actually more like a reference. And I want to use the disclaimer that the standard never tells, like, compiler implementation is not being defined. So when I say a reference to AST, that's not in any way obligatory for compilers to implement that way, but I want you to get the logical idea of how this works. And this res1 is basically describing a state of an entity in the program, but at that point, the state have been modified, and that's not a snapshot of where the expression was taken, but basically an information on this entity that now is actually complete. So we're going to get here false, true, and true. There's two types of type traits, one that query a type and one that modify type, like remove serif would be one that modify. And the main focus of the current proposal P2996 for 26 is to move away from things that modify it, and exceptions to that is define aggregate, and of course you can splice, so you can modify the model. But generally speaking, as there were more controversy, or was more challenging to convince all the parties that are involved in getting the complex aspects of, like, modifying your STY value in it, etc. It was both a pushback from compiler implementers and also from other people in the committee that wanted to get more information before we do something that is more adventurous. So that was basically pushed to a later stage, but it doesn't mean that we're not going to get those kind of traits in the future. And I'd love to hear from you, especially if you have ideas for things that you think that we need. I would love to hear from you, and I'm going to give my email at the end of the talk. So please feel free to reach out, and I expect those to come up in the upcoming years. So another important point to make is that using reflection, we're used to have in C++ access modifiers, and using reflection, we can actually access private members as well. So we don't only access, but we can also assign to it. So the idea is that, as I said, the intention of the feature to be able to represent the structure of a program, and private members are also part of the structure of this type. So hypothetically, we could go the other way and decide that we're not exposing the part, and there was a lot of discussions on those as well. This is supposed to be, but we could also take the path of, for example, Java, that had at some version explicitly marked the classes that are being reflected on by the author of the class. They could opt into being reflected on, but that was not the case here. And I think, the design options are all kind of, all the options make sense, but this is the direction that we went through. So I want to summarize everything that we saw so far. So I wanted to show you also a bit of a example of a potential library that we could have. So first of all, I defined here a const eval function, log members. It takes some meta info. And then I can, of course, I need to probably do some checks here, as I would with other functions as well. But then I can basically print the name of this thing, and also iterate over the non-static data members of, and print them. Note that this is report context where value is like intrinsic of EDG. It's not part of the proposal. But let's execute this code on this struct student. So we execute this and we get exactly as expected, name of the type, and then member and another member, the names of them. So, but what about AI? So you could consider reflection as something, as a tool that gives you the ability to generate code. So naturally, the thing that you might think of is, we have AI, we have generative AI, so maybe that could replace the need to write explicit code that's going to be generated. So I try to explore this a bit, and of course I want to, disclaimer is, the very important disclaimer is that the world of AI moves really fast, and what I've tried to explore today is not the same as what I might get in the future. But I use this prompt, generate my type serializer class in a header based on my type, which provides serialize and deserialize methods for my type, turning it into a buffer and back into my type class. So first attempt, I got back from serialize a type which did not fit to the input type for deserialize, and I consider this as I consider this as a design flaw. So I asked the model to modify, and I went through a few iterations, and I got to something pretty reasonable. But then I wanted to do this experiment again because I wanted to check for consistency. So I did this experiment again in a different basically workspace, because when you open, like in your IDE, some workspace, the agent can actually, and you use the extension, for example, Copilot, it can preserve some information, like cache some information on the previous operations, and I wanted to make sure I start from scratch. So a different project. Then I don't get the problem that we saw earlier, but I do get other APIs and interfaces, which means that if I would try to put this in a pipe and try to generalize or try to automate this, I would get different result every time. And I also would not know how to automatically fix, because there's no input that I can give that is consistent enough throughout different iterations. Now, I would point out that if you give the example, for example, if you give a template example to how you want this thing to work, once you already you have this example and already created existing in class, and you just tell the LLM just do the same thing for this class, it works a bit better. But still, there is no determinism between different executions. So long story short, the way LLM works is by trying to guess, the best fitting text is non-deterministic, somewhat inherently. And especially when I start replacing models or extensions. By the way, for those of you who are not familiar with this, as part of my role in Microsoft, I've been working on also getting more of our group to use AI tools, and I've been exploring and studying a lot of the extensions, etc. But when you replace extension, you basically every extension or every tool can define its own system prompt, and the system prompt is being wrapped around the prompt that the user used, and therefore even if you go into the same model, for example, or querying the same model, if you pick the same version, even it doesn't necessarily promise you that you're going to get the same result, because the system part might be modified as well. So long story short, definitely when we start modifying things, but also between different executions on the same platform and with the same model, we might get different results. Again, so no guarantees between executions, but that's as of now. So again, the world of AI develops really fast. Could be that in the future it will be consistent enough for us to rely on for automated tools. But the underlying point is that once you use deterministic, like feature-like reflection or frameworks like Jinja that generate code basically based on templates, you have the determinism is being guaranteed, unlike with AI. Another point I wanted to make is Rust. So I'm sure you all know that Rust and C++ are both had a lot of discussions in the latest years, and I think Rust is a great programming language. By the way, I think we have a lot of shared and common use cases, and we can collaborate really well to improve both languages, and I think that's what we're already doing. So Rust, does have some abilities to do reflection. It have macros, but it also have the sync library, which is basically a library to inject tokens into AST. It have procedural macros, basically used to process one AST into another. And I've put here a table that tries to summarize what what I consider in terms of how Rust works. But I already talked to you about a bit of the AST, etc. And in my mind, having code that is basically on the level of application code that tries to reflect also need to deal or modify the AST is breaking of layers of encapsulation of the logic of the program. So in that sense, I think that C++ code, as of now, the reflection that we are now having proposed, is actually a very good way to keep separations on responsibilities. And in a sense, someone in the Rust community have agreed with me because first of all, they have been watching closely on what we are doing, the C++ programming language is doing. But second, they actually created, around a month ago, there was a publication, official publication as far as I could find, or the list of, it's still experimental, but at least the most up-to-date and most complete publication of reflectlib. And reflectlib is trying to basically get avoid or get rid of the boilerplate and edge cases and things like that that are needed if you use SYN directly, but it's still working on the AST, working on modifying the AST. So I think in that kind of scope, Rust could benefit greatly from also taking or having some syntax that is specialized for reflection. And I think in that aspect, C++ is doing a great job. I will also point out that we have, as part of the standard committee, we're currently working on starting a combined group between Rust and C++ that's going to talk about the interoperability and other things as well. And that's in collaboration with the Rust Foundation. So I'm really, really excited about how those new languages are going to be able to communicate and develop in the upcoming years. So to summarize, what can we expect from reflection libraries? As I showed you, once we start getting into reflection, exposing to you the internals of implementation, we cannot have any guarantees between standard version in terms of reflection, of course, not in terms of C++ in general. And there's no backward compatibility. If the source code have been modified and you execute even in the private members, for example, you execute your reflection logger, you cannot expect the result to be the same. So the outcome of breaking this is can either be the program does not compile, ill-formed, or it's UB. But we try to do better. And for doing better, I actually need to mention here Hanna Disokova. She worked on const expert exceptions. So it may sound weird at first, but those exceptions do not leak to runtime. And the compiler basically can use those to signify an error better than the current mechanisms that we have. So I think this is a really good step forward in terms of error handling, error reporting. And that's, by the way, not just for reflection. It's also for anything that is compile time executed can use those. And also interesting to think of how warnings might come up in the future and improve the way we read this code. So here's a quick summary of the talk. We had a brief history of reflection proposal, looked at the latest proposal, talked about the complexity and the non-intuitive cases, talked about reflection-based libraries, and maybe what's next. And I would love to hear from you which reflection libraries you think should go into the standard library. Please feel free to reach out and give me more information and talk to me about that. And that's exactly the kind of input that I'm looking for. One more thing I wanted to point out is Daisy Holman. She's a committee member as well. She recently joined Anthropic, and she gave a really good talk around 2 months ago about how models work, how LLM works. And she also did some really cool experiments in regards to C++. So the video is not available yet, but the slides are, so I linked them here. Please check that talk out if you want to learn more about LLMs. So I want to thank Core CPP user group, our local user groups, who are seeing early versions of this talk. To Hanna Disokova, which is SD7 chair. So SD7 is the group that is in charge of compile time inside the C++ standardization committee. This is like an incubator, and have been incubating this proposal until it got to the design group. So thank you very much for her contribution as well. And by the way, she speaks in this conference, so you can also use this opportunity to send her a message and thank her. To Matush and David Sankel, Corentin, Louis, and Adi for reviewing this talk, and to all reflection papers authors, not just the main proposal, but also all the ones that contributed fixes and gave feedbacks and so on. Thank you for being passionate about C++. Please stay in touch and feel free to email me. And I also want to thank Sai for organizing this great conference. Thank you very much and enjoy the rest of your conference.